So now let's go back to now that we understand the LLM infrastructure, that there is an LLM deployed in Selector, now John's going to show you those queries that we went through earlier and more details on the SQL that gets executed, a more interactive experience. So the first customer is a transit provider who has a backbone kind of network in the middle, and it's connecting data centers. And somebody has complained that there are some issues going from data center A to data center B, and most likely that's issues happening around Denver. How does one go interactively and get to the root cause of that? And I just want to preface that this is an interaction. There are automated root cause analysis that is available, but this is how you would interactively go about finding that answer.
Yep. So yeah, please chime in. As I kind of go through this, I'll explain a little bit about the platform, what you're seeing as well, to kind of bring it all together. So right now, we're going to go through the 3 demos that we showed in the video live, and we'll do it slowly so you can kind of see what we did a little bit behind the covers. In this case, we're using the Copilot feature built into the stack. This could be via Slack, WebEx, Teams, like pick your collaboration client, the same results can happen. So the first thing I did is I wanted to see latency seen by all transit routers. And you can see I got a visual as well as a textual representation. Now, what I'm going to do is build an ad hoc dashboard. One of the things we've kind of heard from customers is, we have too many dashboards already. I like this because I think this is like you're building dashboards on demand as needed versus like having 1,000 dashboards for every scenario on the network. Which really doesn't scale very well. So what you'll see here is I've asked it a question. I've got my backbone devices. I got a couple different core sites there, and I see I have a couple in red. So in this case, by hovering over that, I'll see more details about those 2 sites. Selector has synthetics. We call it ping mesh. These are deployed across this backbone, so they're constantly pinging each other, doing trace routes, understanding paths, and finding anomalies in that using auto baselining. To show a little bit more about the query, this is what I typed. But this is what the LM inferred, right? Latency as threshold violation. So latency in this case is the metric we're querying. Threshold violation matrix is this display right here. And we said we're a host equals transit routers. So that's kind of basically what happened behind the scenes as I typed this. So now what we'll do is, let's just say this particular person doesn't know the network topology, or maybe they're just trying to understand a little bit about the topology. They can ask it that question. And so as I ask it these questions, what I'm going to do is bring these over to the main dashboard to make it easier to see. So everybody has to stare at the laptop and kill their eyes. What I want to do is highlight a couple of things. One is, as I zoom in here or here, I'll get the same view of the topology. It actually goes into every circuit that's connecting these things together. As I hit this I button, I type network topology. It now knows layer 2 topology as topomap. So layer 2 topology is the metric, topomap is the visualization, and this is the filter it referred to, show by device, A, Z device, interface, et cetera, et cetera. So it now did that. And also what's kind of handy is, we have these, if you like this, you can either share this to another collaboration client, you can hit this API button and you'll get the API query just like that. Very, very cool in the fact that you can generate this to other applications as needed.
And this is the aspect of democratization. Look at the SQL query. It is complex. It's complex for a reason. Only experts will be able to do it. But somebody who's not very familiar with that particular aspect can just say network topology and then get that.
So next, because up here I saw these were related to Denver, I'm going to ask for the topology around Denver. And again, I'll bring it over to the bigger dashboard. And so what you'll see is 2 things have changed. I now say where site equals Denver or Z site equals Denver. So A or Z equals Denver. And the rest is kind of the same. So this map is now this map. And if I zoom in I'll see the different elements. I can also click on these elements to get more information. So I have the nodes, which are the devices in Denver. I have the edges, which are the interfaces. And I have the topology of Denver as well. So we call this a query chain. It's the ability to take a high-level piece of data, click on it, and pull in a bunch more context. These can be built custom, depending on what a customer wants to pull in, or we have our own kind of generic ones that we've applied to multiple customers. But the goal is to give quick context to what's going on.
And then is this only data from the network itself, or is there a way to get real-time data from third-party sources? What I'm thinking about is, let's say your network vendor just put out a bug report or something, or there's a security vulnerability report. There may be something outside of your network that's causing this problem. Is it possible to have that data available?
Yes,
Well,
because the ingest layer can connect to infrastructure devices. The ingest layer can connect to other sources as well. So if the security vulnerability is available in a website or in a URL, you can bring that in. And then the correlation aspect, which I did not cover today, would correlate that information with the other networking data that you get, so that you can see it in a hover like this, that, oh yeah, this device that you're seeing, it just had a vulnerability. All of that would be available. It's in the storage layer already. Then it becomes a problem of how do you query it and show it over here.
But that actually has come up quite a bit from customers, is hooking up the knowledge bases for certain vendors. If you know my device, you know my model, you know my OS, tell them what the vulnerabilities are, especially if they match an event that's happening on the system. It just saves that time for the human. So kind of like Nick was showing, now I've asked it for circuit errors. In this case, it's going to pull errors, circuit errors in rate color. So it's actually going to give me a color indicating if the link is good or bad. What I can do too is I can highlight just the bad link. So now I see this is the actual problem in my network. Kind of to show more about that query chain, if I click into this, it will now actually bring up the circuit. So in this case, it's between two devices, Cincinnati and Denver. I have the KPIs for that circuit, like DOM power. Pretty easy to see, right? I have an if operator status down on both of them, a status change alarm. Then I have errors on the Denver side. And so down below, I'll have more context about the logs for these devices. I'll have device events. I'll have the circuit names, descriptions, and whatnot. So these things can generate tickets straight into a ticketing system. We're showing you here is kind of how you could use the Copilot feature to do this kind of somewhat manually. And I'll switch to the next demo. I'll set that up here, and if there's any questions, yeah.
So the next demo is around the multi-cloud operator. They are operating a backbone within quotes across different clouds. They use transit gateways. They use AWS constructs. So they have built a network, and then they have tenants to whom they're providing connectivity, right? So as you can see in such an environment, they are heavily dependent on the underlying cloud infrastructure, how that is behaving. Have they provisioned the cloud infrastructure properly? So there's a lot of variability, a lot of analysis that they have to do around that. So they just heard that there was an outage in US East. They want to see, okay, who got affected because of that.
And so what you'll be noticed is like when I go to the I button here, we now are showing a tenant status is the metric. So when Nitin was saying we have a declarative ETL, in this case, tenant status is the metric we've defined in that ETL to define a customer status in their environment. And then honeycomb is basically one of our representations, and it's just a nice efficient way to show multiple types of data. And then we use color coding to say how bad a thing is. If it's red, shades of orange/yellow, then green if it's good. In this case, we have 3 or 4 tenants or customers that are having problems. And so what I'll do next is kind of show you some other examples here. In this kind of scenario, we have an issue where we've seen these tenants burst beyond their provision capability, right? So I can actually see that here. So I'm going to ask it for tenants that are bursting beyond their allocation. All right, tenants are bursting. And so here, what I'll get is a line plot. So as we were saying, we have different types of representations. Still have tenants in this query, but I'm saying discard percentage line plot. So it's actually looking for traffic or the percentage of traffic being discarded, these ones. But now I'm looking at the region US East because that's the one that we were looking at in our previous example, right? That understanding context. What I also like too is that you can look at historic data. So maybe, if I'm an operator trying to do some analysis on this, I could say, look at historic usage in the East. And I'll bring this over to the main dashboard so it's easier to see. In this case, it's a similar query, but if I click on this I button here, come on, I'll click it over here maybe.
That's all right, we can move on.
Yeah, you see it went back the last 30 days is the point. So it's going back in time, looking at this same data over a historical period of time. At the same time, I can look into the future. Oops. Give me 1 second. I lost the ability to type into here. I don't know what's going on, but hold on. All right. So we'll finish with show projected usage. And we'll get all that back. Bandwidth. For tenants. So we're actually going to go look in the future, tenants in US-East. And we'll drag this over as well. And I love it doing it live, as well as the actual text happening here. Okay. It doesn't like the multiple screens here. So this is kind of what we showed earlier, right? In the sense that we have our historical. I can click on a given customer, and I can see its historical usage as well as projected usage. And this works for any of these queries, right? I can always pick on a type of entry in that, if it's a customer, if it's an interface, so on and so forth. And so the point here is you can look from the future, you can go in the past, all through the Copilot feature.
So if I have a bunch of optics, can you project when my optics are going to fail?
If the failure reason is slow temperature creep or voltage fluctuating, so you would see, we would actually be able to alert that as well, because you can see the temperature slowly grow and you can compute the slope of that. If that is the reason for failure,
Right.
If the reason for failure is dirt and all that, probably not.
Yeah. But usually it's temperature. I mean, usually it's as an optic gets really hot, then it will fail.
Yes.
So theoretically, you could project that.
And that's how we haven't productized that feature just yet. We would tell you that you're gonna hit this particular temperature in the next whatever 30 days, and if that projection ever changes, alert me right away, because you might be okay for memory to grow up to whatever 30 days. So as soon as that projection changes, let me know. So that's how these future time plots are useful. Because yes, there's one reason why you can just look at them and see how things are going, but you cannot be staring at dashboards all the time. So you convert that into an alertable event that you can react to.
So that's an interesting piece. I mean, we've talked a lot about the language model piece of being able to make these human language queries into the data that's there. With that piece, right, the correlation, causation, kind of digging into this, as Jeremy said earlier, right, the microscope versus the doctor. Does that use AI also, or is that more just straight limits and trends?
No, I'm going to talk about that after this. So this is the browse interface. I'm going to talk about the alerting interface, and all of that would be covered as part of it.
Excellent.
And this is the other one.
Yeah,
this is the retail customer. They have a lot of stores across the country, and these stores are talking to applications running in public cloud. How do they go about this is a workflow of, if they're seeing some issues in Atlanta, how do they go about finding the right circuit provider or the internet provider to file an incident?
Yeah, and so the first thing they can do is ask for the current packet loss. This is a real-time view of it. In this case, now I'm going to go, all right, I'm going to look at latency to AWS. So I'm looking at just a certain cloud provider from Atlanta, because they've been complaining about, in this scenario, about some issues with their connectivity. And I'm asking for the last 2 days. And hit enter here. Let's see, from there we go. That's part of it, right? Sometimes you have to get the structure of the request right to get the actual data back that you want. And so, that's how you know we're doing it. So in this case, I've asked for it for the last 2 days. And you'll see right here, right, I'm actually saying it's going to write that into the query that's saying go back in 2 days. And so I have my latency event that we're seeing in this case. A scenario might be that, okay, if I have something going on here, what are the providers that we talked about in the earlier demo? Show me the providers in Atlanta. So I can ask it that, show me providers in Atlanta. And if I do that, I'll get the 3 providers that we have, as well as just a text saying the same thing. Now, maybe I want to see the errors in those providers. So in this case, it'll infer the type of errors I want to see, errors seen on providers. And so I'll do is I'll drag this over once it's done. And I'll scroll down, and to make this easier to see, I'll do this. So you can see these are the providers we have. We can do simple filtering here to kind of eliminate one provider to do more analysis. As Nitin was kind of saying, in this scenario, we're saying Verizon is a problematic provider. We've known we've had some issues in here. So actually, I want to just see the provider, the errors for Verizon. So I can ask that as well as saying errors seen on Verizon for the last 2 days. And what we're going to do here is something different. We're actually going to ask it the question. We're going to bring it back over to the dashboard once it kind of stops telling us this data. And we're actually going to then expand it. So one of the things we do a lot is, in this case, let's say I want to look at just Atlanta. And I didn't ask that in the query, by the way. And so now I've typed in ATL, and I have just the ones that are Atlanta. And maybe I can say I have 3 here. In this case, they're happening pretty frequently. What we can do, and this is pretty common for our customers, is they can take these events, they can collect them together organically, right? They can then attach to an incident. So in this case, this incident now has all the tags, all the metadata we know about this device, these interfaces, we have the actual events. I hit create new incident, it's going to generate this into whatever I provision for an ITSM integration. So it could be ServiceNow, could be something else. I can set my priority, I can define certain characteristics of it as well. We have other customers that auto-create incidents with all this context. I think Nitin shows next. But there are other workflows that are going to create them manually based on the kind of the work they're doing in the research in the ticket or in the event.
Cool. For the latency data, does that mean or I guess maybe the question is just how are you getting latency data? Are there agents deployed in the network to be able to, or how?
So there are a couple of ways. So we build synthetic agents, and those agents can be deployed across infrastructure, and then they ping using UDP packets, and they figure out loss, packet loss, latency, jitter, trace route on all of that. But a lot of our larger service providers, they have their own agents. They have deployed their agents on their own, and they have collected that data and put them in databases. In that case, we connect to that database and get that data in. So both options.
Makes sense.
It's kind of the question earlier. If it takes us a month to go deploy 1,000 agents, or it takes us 2 hours to get it from their database, we choose 2 hours and give us that. It just happens way quicker. So we always prefer data that's already onboarded if possible.
So most of your customers already have a data lake of some type that they're doing data aggregation
Right.
for all of them.
Any enterprise customer has that, but it's in their own format. And so it's a matter of kind of like you said, is using a hypervisor to go extract that data, normalize it, and then enhance it with the metadata too, which is the big key.
Can you guys talk a little bit more about that statement? Like, what does that mean? How does that work? How does somebody get you the metadata? Who does that work?
Okay, all right.
If not now, later.
Now is a good time as any to talk about metadata. So as you can imagine, you have metrics and events coming into our system. You need to be able to annotate that with other metadata, customer IDs, uplinks, sites. There are a lot of other information that you might want to annotate with that. So there are a few ways in which that data from a customer's environment can show up in our stack. There are metadata stores like Netbox, Notabot, what have you. So customer has already deployed that, and they are feeding in all their data over there. Right? So we provide a Netbox integration where you configure the Netbox integration, and we understand the Netbox schema, and we pull everything in, and then you can curate. And that Netbox connection is just another data source for us. Just like we connect into devices and use SNMP to pull the data, here we connect into Netbox, we understand that schema, and we bring the data in. That's one way of bringing the data in. Second way is customers sometimes have spreadsheets or just documents lying around on some HTTP server, and they give us access to that. So we connect up to that. We bring that data in. Depends. So and sometimes they have other CMDBs like NetMRI is another CMDB that customers have deployed. We connect up to NetMRI. CloudGenix has their own repositories. We do all of that. Once the data comes in, there's one more source. Sometimes sophisticated customers might have their own software development teams. They want to publish metadata into our system. So we have an API interface as well that you can bring in any kind of metadata that you have manufactured on your side, and then create a meta store on our platform, and using APIs push over the metadata. For example, you might want to say, I expect so many prefixes from this tenant. I expect so many errors on this. So all of that information, which is built into rules on our customer side, they can send over metadata and publish into our system. Once it is into our system, then the metrics that come in are then consulted with the meta stores, and they're enriched and augmented. And that all of that context is now available to the SQL layer. Right? Is there anything else that you wanted to see in
I think that makes sense. Yeah.
And
So can we also send it, Michael Winston, can we also send it streaming data via GNMI or some other streaming protocol? So that
Yes.
this way
yes.
some of the more real-time information can get in there?
Yes, so it could be, so that is a property of the ingest layer. It could be streaming telemetry like GNMI. It could be even a Kafka bus. Sometimes a lot of our customers have streaming data available in Kafka. So we just connect up to the Kafka bus, and then streaming data starts showing up. And it could be just records that keep coming into us, and we then ingest them into stores.
So in that case, then you would have to, in your data hypervisor, you would have to know the structure of those message packets,
Yes.
map them into fields, and then any kind of extra context, I guess, or metadata that's in your meta store, it gets automatically attached.
Yes,
Yeah.
yes. And just now that we're talking about meta stores, another use case which I did not anticipate when we built the system, once the data is inside in our store, and you have a SQL interface to that, a lot of data rationalization can be done. Because when you are working with Netbox or you have your own spreadsheets, you don't necessarily see, is there anything wrong in my data? Like, are my interface descriptions all uniform? Are my interface descriptions missing? I'm supposed to, I think I've told my teams to do this, but how much have they actually done? So if the teams are actually fixing interface descriptions, are they 80% done? Are they 90% done? What am I looking at? A lot of our customers are able to look at the meta stores that they've built in our platform and just use SQL queries on an ongoing basis to make sure things are valid. For example, they've built dashboards. That dashboard is called an inconsistency dashboard. That dashboard should always be empty, right? And you can set an alert. If a row shows up in that table, then there is some inconsistency somewhere. I need to be taught about that, right? So those are, once you have a SQL interface to a table, a lot of things can be done, which you traditionally are not able to do that because because SQL gives you a great facility to slice and dice and just look at different things. Yes, you can do spreadsheets, you can do all of that, but how does your data get into the spreadsheet to start with? So a lot of that capability, which I did not anticipate early on, is being actively used. And the interface description one is really one that caught my eye, that they know that the interface description should look like this, but it doesn't because for whatever reason, and they look at the inconsistent dashboards and see which needs to be fixed.
So then the meta store is kind of acting, I hate to use the word intent, but it's kind of acting like an intent store. It's like,
Yes.
This is how I want things to be or how I expect things to be. And then your system can use that to correlate or use it to even set thresholds for metrics or however you're going to process that data.
Yes, yeah.
One last thing before we move on. I'm just thinking through, like, I guess maybe how many boxes I need to deploy. What I mean is the data like aggregated locally and then sent over like TLS tunnels over the internet, or how are you getting all this data? I'm assuming this is kind of back in your cloud is where most of this is happening.
Yes.
So how do you get the data from the network to Selector?
Right. So most of the times, the collection layer is separate from our cloud because the collectors have to be deployed on-prem, right? And the collectors are very efficiently written. We've seen that a reasonably sized VM can poll up to 5,000 to 7,000 devices, right? So if you have a fleet of, like one of our larger customers has a fleet of about 30,000 devices, we have about 8 or 9 pollers installed globally. So these pollers are polling locally, and there's of course HA and redundancy built in. You most likely want to have 2 pollers, and you can load share that if one poller goes down, the rest of the infrastructure pollers will pick up. All of that facilities exist. Once these pollers collect the data using HTTP TLS tunnels, they publish up to our cloud. Our cloud, I'm just using metaphorically, it would be the customer's cloud. You would be deployed in their public infrastructure. Few of our customers actually let us deploy in our cloud, so it's a mix of customers, what their security policies say. And then in our cloud or in our customer's cloud, it's a very, since it's all Kubernetes and it's an elastic infrastructure, depending upon whether the query load is high, you can dedicate 2 nodes to the query infrastructure. If you want to have a lot of retention, you can scale the storage layer accordingly. So it depends on what is the customer policy. You want to retain the data for 9 months or for 30 days, you have to give it that much storage. If you anticipate 1,000 users querying the system all the time, you need to dedicate multiple nodes for the query layer. So and everything, because of Kubernetes, everything can be scaled out independently, and that's one of the reasons why we've been successful, because we don't show up saying that we need 1,000 servers, because most likely not. We can start slow, small, and then grow organically as more and more data is pushed into the system.
So since you broached the subject of the managed service, I feel I get an in to ask my question.
Sure.
Do you support, if we wanted to use it in your cloud, customer managed keys for encryption?
I did not. Could you repeat the question?
So a SaaS provider holds our data. A number of financial services and other regulated companies require they control the encryption of the data so that you can't reuse it or do anything with it outside of where the data is loaded. So we use customer managed keys, or CMK, in order to encrypt that data. It's a endpoint you can subscribe to, and we provide a key. So, and maybe that's too deep and we can take that offline. Because that for a number of those customers is important to be able to control that data access.
Right. So far for customers who have those kind of encryption requirements and they require external encryption, they most likely have their own cloud footprint where all these policies are in place. So they do it locally on their side, and we would not do it in our cloud. So that would be a use case for they are hosting the infrastructure on their side.
And just
I have a lot more questions, but we can take it offline.
Okay.
no, just to also clarify that point, the deployment can be in our cloud and could be in customer premises, or it could be also if the customer has their own AWS GCP cloud instance, they can give access there also. So the way it is deployed, depending on the security posture, it can be in any place, and it's completely the same identical stack which is deployed in all these 3 places.